Okay, so we're back. Little interruption there. We have 3 petal rows we're going to be looking at. And again, we're going to have a sine type and a cosine type. So, for the sine type, the form is going to be a times the sine of 3 theta. A is going to be constant. And theta is going to be from 0 to 2 pi. Now, interestingly, notice that the number here in front of the theta within the argument, that's an odd number. So when you have an odd number, you're going to have an odd number bigger than 1, that's going to tell you just have n petals. So rather than doubling the number like with the even number, rather than doubling, you're just going to have, in this case, n petals. So in this case, it would have been 3 petals. So n petals if n is greater than or equal to 3. So if n greater than or equal to 3 is odd, I should say, is odd. Yep. So in general, if that n there in front of theta is an odd, that's bigger than 3. 3 or bigger, you're going to have a rose with that many petals. If it were even, like before, remember when we have the even, like in this case, you're going to double that number, take 2 times that number, like where earlier we had 2 times 2, which was 4 petals. Odd number, you just have the same number as that number. Same number of petals as that number in front. So we're going to have a 3-petaled rose. Try to graph this out. So I'm going to start with a radius of A here. And the way this one starts at the origin, and it goes up here in the first quadrant and forms a petal. And then it goes down here and gets another petal straight south. And then it loops up into the upper left. And then it comes back to the origin. That's from 0 to 2 pi. The 3-petaled cosine is what we want to do next. The 3-petaled cosine rose. If I take a times cosine of 3 theta, a is a constant. The angle is between 0 and 2 pi. Now this number 3 here is a number in front of the theta within the argument. So when you have a non-number bigger than 3, that's going to tell you you're going to have a rose with n petals. So here we have n petals, which 3 petals in our case. If n is greater than or equal to 3 is odd. So to graph this one, we're going to first think about a circle of radius A. And we're actually going to start here on the horizontal axis out a distance of A, and that one is going to go a petal around, half a petal around to the origin. And then down into the lower left, we get a petal. And then up into the upper left, a petal. Back to the origin, and then finish that half petal that we began, and we end up back at angle of 0 and a radius of A. So that's right there on the horizontal axis at A. Any others worth mentioning here? Oh yeah, we want to mention lemniscates. Lemniscates. We're going to talk about a diagonal lemniscate. can I spell lemniscate? So lemniscate is like an infinity symbol. So we often write that as r squared equals a squared times the sine of 2 theta. And here a is a constant. And the angle theta is between 0 and 2 pi. Another way you'll see this, sometimes you'll see this as r equals a times the square root of sine of 2 theta. That's another way you'll see this. So I'll make a horizontal and a vertical axis. We'll start with a circle of radius a here. And we're going to inscribe into that sort of an infinity symbol. So this actually starts at the origin, and you get a big loop in the upper right. So it starts at the origin, it goes out to the radius. Oh, it's going the wrong way. Out there, and it comes back to the origin, and then it loops in the lower left. Ends back up at the origin. It's erasing. Try that one more time. Okay, that's a lemniscate. Now that's sort of a diagonal lemniscate. That's a sine lemniscate. Now there's also sort of the horizontal lemniscate. That'll be the cosine one. That'll be of the form r squared equals a squared cosine of 2 theta. Here a is a constant. The angle theta is going to be between 0 and 2 pi. Or you can rewrite this as r equals a square root of cosine 2 theta. You'll see it that way. So I'll begin with my graphing with a vertical and a horizontal axis. Circle of radius a. And I'm going to inscribe into that my polar curve here. I'm going to start here at the angle 0 and the radius of a. I'm going to start a part of a loop, then go to the origin, and I'm going to finish a loop on the left side. And then once I'm back to the origin, I'm going to go and finish the bottom half of that first loop I started. So again, that's starting here and then going boom, boom, boom. That's a cosine lemniscate. I think if there are any other big ones, I think those are probably the ones I want you to know. So as far as exercises, let's see if we can sketch some polar curves. Sketch the polar curve. So for number 1, I am going to give you r squared equals 4 cosine of 2 theta. So that would be this one right here, right? A horizontal lemniscate. You'll think about what your a is here. Oh, this is actually our a squared right here, right? Our a squared equals 4. So actually a is equal to, take the square root of 4. You get a is 2. This is a horizontal lemniscate. to graph this, horizontal vertical axis. So imagine I go out 2, and imagine I have a circle of radius 2 here. I'm going to inscribe in that circle of radius 2 a lemniscate. It's horizontal, so I'm starting here to the origin, to the far left, and then loop around back to the origin, and then back to where I began. I'm drawing arrows so you can see what path I took. Do you have to draw the arrows? No, but it can be useful for some other stuff we'll do. Here's a number 2. Let's say we have r equals 2 sine of 3 theta. So keep in mind that when you have the sine of a number times your angle, this is going to be like a rose. Now, this is going to be a rose. It's a sine rose. And since we have n, here is odd, right? N is odd, n equals 3. It's odd. Remember, when you have an odd number there, you're going to have that same number of petals. You have n equals 3 petals. This is 3 petaled rose. You take n equals 3, and you don't double it. You only double it when that number is even. Since n equals 3 is odd, you just keep that number, so 3 petal rose. Okay, so we're graphing a sine rose. Sine rose. And it's 3 petal. So here goes. We have, what is this? Horizontal, vertical axis. And we go out a radius of 2. And your sine, the rose starts here at the origin, and it goes up in the upper right, loops around, forms a petal, and then it goes down, straight down to form another petal, and then it goes around in the upper left to form your last petal, heading back to the origin, where it keeps repeating and keeps repeating if you increase the angle, definitely. Anything else? No, that's it. That's pretty much it. Okay, here's a number 3. Let's say I take r equals 3 times the sine of 4 theta. Now notice here we got the sine of 4 theta. So because we have a number here in front, of our angle, that means we're going to have another rose. So we're dealing with a rose. And we have n equals 4. Since that's an even, remember you have to multiply by 2 to get the number of petals. So n equals 4 is even. So we're going to do 2 times that number to get the number of petals. So it's going to be 8 petals. So an 8 petal rose. This again is a sine rose. So to graph this, I'm going to start with my vertical axis, horizontal axis. We're going out a radius of 3 this time, right? That number out front, that's our A is 3. Maybe I should have mentioned that. So last time our A was 2, this time our A is 3. So we're going to have to go out a radius of 3. 1, 2, 3. And we have to construct an 8 petal rose. I don't know if that's a big enough radius. Okay, that's proper, I guess. Now, how does this one work? This one's tricky. So it has 8 petals, so you're going to have 2 petals in each quadrant. So I think it does something like this. It starts here. It goes here. then here, and then here, and here. Ooh. And here, and here, then there. Okay, it's an 8-petal rose. And then back to the beginning. 1, 2, 3, 4, 5, 6, 7, 8. Tried to draw the arrows correctly. All right, here's a number. Okay, that's 3. Radius 3. Oh, let's say we have a number 4. We have r equals 4 theta. So that's going to be an Archimedean spiral. Archimedean or Archimedean spiral, however you want to say that. Archimedean. So here you have an A of 4, right? This is your A. So the thing you have to remember on this one is you have to take 4 times 2 pi out here. 4, which is A, 4 times 2 pi is 8 pi. That's where you're going to end up. You're going to start here at the origin, and you're just going to kind of twist out until you get there. And that's probably not the most accurate. Let me try that again. Something like that. Okay. Archimedean spiral. There are the arrows. What else? Now, what if you mix it up? How is this? Number 5. So we take r equals minus 3 cosine of theta. Here, theta is just between 0 and pi. So if I had r equals 3 cosine of theta, we would go out 1, 2, 3 and start when the radius is 3 and the angle is 0, and we just go around like that, right? If it were positive 3, but we have a negative 3. Well, basically what the negative 3 does, it flips everything to the other side of the origin. So the radius, which is positive 3, gets flipped to the other side of the origin. This is still a radius of 3. We use a positive number to represent it. You don't actually use a negative number in the polar coordinate system here when you're writing this out. This is a radius of 3. So the angle is 0 here, right? Imagine having an angle of 0 and then a radius of negative 3 that flips it over here to that side to get a positive radius of 3. So here you go. And this is going to rotate around like that. You actually start here on the left side. Okay. Anything else we want to look at? Oh, let's do one more. Number 6. So we have r equals 4 times 1 plus the cosine of theta. If you distribute this 4 here, you can write this as 4 plus 4 cosine of theta. So here you can tell this is a cardioid, and your A is 4. This is a cardioid. And it's a sine cardioid, so it's the horizontal type. So to graph that one, we're going to go here on the horizontal axis. 2 times A. So that would be 8 out here, right? 2 times A is 8. On the vertical, you're going to go at a radius of A, which is 4, and on the downside of the vertical, you're going to go at a radius of 4. So that's a radius of 4. So you actually start here on the horizontal axis, out at 8, a radius of 8. You're going to go 4, and then pinch in at the origin, and then go down to 4 there, and then loop back around to your starting place. Okay, let's think. Anything else we want to do? I don't know. I think that might be it. And that's it.